Aluminum starts here, with bauxite ore mined from open pits like this. Massive hydraulic excavators dig the ore directly from the exposed mining benches. The ore is loaded into heavy-haul trucks for transport across the mine site. The ore is dumped into a hopper where crushing begins. Crushed bauxite is carried by conveyor towards stockpiles for further processing. The conveyor discharges ore continuously, building the pile outward, because stockpiling ensures steady feed to the refining plant.
From this mine, the journey continues to refining, where bauxite becomes the foundation of aluminum.
After mining, crushed bauxite enters the refining plant, where aluminum compounds are separated from the rock. The ground bauxite is mixed into slurry and pumped into high-pressure digesters.
Impurities settle as red mud, while aluminum remains dissolved in solution. Filtration removes excess liquid, leaving solid aluminum hydroxide.
The result is alumina, a fine white powder that becomes aluminum metal in the smelter.
In the smelter, alumina is transformed into pure aluminum through electrolysis. Automated feeders keep the alumina level stable inside each cell. Molten aluminum is periodically tapped from the bottom of each cell. Molten aluminum solidifies into large slabs for rolling. From molten metal to solid slab, the aluminum is now ready for rolling into sheet. These aluminum slabs are too thick to become cans, and they must be rolled into thin sheet. The slab is reheated to make it workable for rolling. Each rolling stand progressively thins the aluminum. The strip passes through precision cold rolling stands, equipped with polished, hardened steel rolls inside a rigid. Cold rolling brings the aluminum down to the exact thickness needed for cans. From slab to coil, the aluminum sheet is now ready to become millions of cans. After rolling, the aluminum sheet is wound into massive coils and prepared for shipment. Each coil weighs several tons and must be secured carefully before transport. Specialized forklifts unload the aluminum coils at the can plant. Now inside the can plant, the aluminum coil is ready to begin its transformation into beverage cans.
To remove coil memory before cutting.
The leftover aluminum web is chopped and recycled. From coil to blank disc, this is the first shaping step inside the can plant. Each aluminum disc is fed into the cupping press one at a time. In a single stroke, the disc becomes a shallow aluminum cup.
The sensor checks cup presence and alignment, because misfeeds must be detected early to prevent jams.
This shallow aluminum cup is the foundation of every beverage can. This is the body maker, where the shallow cup is stretched into a full-height can. Each ironing stage makes the walls thinner and the can taller. Air ejection removes each formed can body from the punch in milliseconds.
The body maker runs continuously, producing thousands of can bodies every minute.
From shallow cup to full-height can body, this is the core forming stage. After ironing, the can body is slightly uneven at the top and must be trimmed.
We are now at the final rinse and drying section. Heated air blowers direct high-velocity air around the trim.
Only perfectly clean aluminum can move to the coating stage. Before any beverage goes inside, the aluminum must be protected with an internal coating. A measured spray of protective lacquer coats the entire interior surface. Heat inside the oven permanently cures the protective lining. Each batch is tested to ensure the interior coating is fully intact. With the inside protected, the can now receives its external design.
Each color is transferred in sequence using high-speed offset printing.
The printed design is baked to permanently bond it to the aluminum. Automated vision systems check alignment and color quality on every can. The can body now enters the necking machine, where the top diameter is reduced in stages. Each station reduces the diameter a little more to avoid stress cracks. The flange provides the contact surface for the lid. The double seamer folds the lid and flange together to create a leak-proof seal. Every finished can is tested to ensure the seam is airtight. High-speed cameras check every surface for defects.
enters a grouping section where mechanical lane dividers organize cans into precise rows before packaging, because consistent grouping is required for high-speed packing.
Cans are grouped and wrapped for efficient distribution. Robotic palletizers stack the finished cans onto shipping pallets. From raw ore to finished package, millions of ready for delivery.